Hello class, today we're going to be talking about translations and reflections 8-1 and 8-2. And the first part we're just going to talk about translations for now. And here's our definition. Our translation is when a figure slides from its original spot to a new spot without changing its shape or size. And it's important that you underline slides, because we're going to be looking at these on a coordinate grid, and we're going to have a shape and it's going to slide left or right or up and down, and sometimes even both. And so a way we can look at this differently is with the algebraic expression. And so we have our point x comma y, and it changes from x plus a and comma y plus b. So I'll give you all some time to write this down. A translation: when a figure slides from its original spot to a new spot without changing its size or shape. It just moves from one place to another. So in our first example, we're going to look at two shapes. And the first thing we have to do is understand which one is the original. Because remember, translation is when our original figure slides to create a new shape somewhere else. And so here we can look at the points, see we have A, B, C, and D. And then over here we have A prime is a little comma right there, B prime, C prime, and D prime. When we just had the A, B, C, D, that means it's our original shape. And so we had this shape slide to this spot right here. And so we had to figure out what happened to our x comma y in order to get here. Okay. So our A is -5 comma 4. And our A prime is 3, 3. So how do we get from -5? How do we get from -5 to 3? Well, from -5 to 3 to add 8. And then we look at 4. How do we get from 4 to 3? And in this case, we just subtract 1. So for A, our x's, we added 8. And for our y's, we subtracted 1. And now we're going to look at other points to see if that was always the case. So for our x's, -2 plus 8, we get 6. And then our y's, 4 minus 1, we get 3. So C, we had -6 plus 8, we get 2. And then 2 minus 1, we get 1. So far it's working. Now we're going to look at our last point, D. -1 plus 8, we get 7. And then 2 minus 1, we get 1. So in this case, now if we want to write our algebraic expression, we have our x comma y, and it changed. Our x's added 8, so we'll have x plus 8. But our y's, we subtracted 1. So we'll put y minus 1. We have our original shape with its coordinates, and our new shape had the coordinates of x plus 8 and y minus 1. In the second example, we're going to look at our original shape, but this time they're going to give us the algebraic expression, and we have to figure out what our new shape is going to be located on the grid. So we have x comma y, and then we have x plus 4 comma y minus 6. So we're going to look at our coordinates, and we're going to apply this to here to find our new shape. So x plus 4, if we look at A, -5 plus 4, we get -1. And then y minus 6, 4 minus 6, we get -2. So we know if we're looking at A prime, our new point, it's going to be -2, -1, comma -2. So now we look at B, so B prime. -2 plus 4, we get 2. And then 4 minus 6, we get -2. C prime. Add 4 to -6, we get -2. And then we subtract 6 from 2, and we get -4. And then our last point, D prime. Add 4 to x, so -1 plus 4, we get +3. And then we're going to subtract 6 from 2, we get -4. So we have our 4 points, and now we're going to plot them, and then create our shape, and then we have our answer. So -1, -2, -1, -2, 2, -2, and then -2, -4, 3, -4. So they're all out here. And we can connect them. And there we go. We have A prime, B prime, C prime, and then D prime. So in this one, we took the algebraic expression, applied it to each point, and it gave us our new shape. Okay, in the second part of this video, we're going to talk about reflections, 8-2, and it's about reflections. So reflection is a mirror image of the original figure, and I put in quotes flip, because it's like it flips across. And so we have two different algebraic expressions because there's two different types of reflections. You can reflect over the x-axis and the y-axis. So if we flip over the x-axis, it's x comma y, and it becomes x comma -y. So the x stays the exact same, and then for y you just change the sign. And if you reflect over the y-axis, it's x comma y, and it becomes -x comma y. So our x's change signs, but our y's stay the same. And this one will make a whole lot more sense when we start doing some examples, and you actually see the shapes, and they reflect. So reflection, a mirror image of the original figure. Now I would put quotes around flip just so you know it kind of flips. Okay, so we're going to go ahead and look at this first example. We have our original triangle. It's A, B, and C. And I went ahead and put the right angle in there so it's easier for y'all to see where it flipped. Okay, so we have A, B, C. A is -2, 6. B is -5, 2, and then C is -2, 2. And so the first one I want y'all to look at is when it flips across the y-axis. And so first thing we want to do is kind of label our points, which one's A, which one's B, and which one's C. We know C is next to the right angle, so here we're going to have C prime. A is at the top, so this is going to be A prime. And then B is over here, so we'll have B prime. And now we need to figure out what are our new coordinates. Well, don't forget about our algebraic expressions. And the one we want to look at is the y-axis, because this triangle here flipped across the y-axis. So you look at the y-axis, x comma y, and it becomes -x comma y. Well, here you'll see that our x's are already negative, so when we apply another negative to it, it'll make them positive. So here, -2 will become 2. We're just changing the sign. And then remember, our y stay the exact same. So we'll have +2, +6. For C prime down here, this -5 will turn into a +5. Oh wait, for B, it'll be 5. And then we keep the 2 the same, so it'll be 5, 2. And then for C, the -2 will become a 2. And then the y2 will stay the same. So our new points, 2, 6, 2, 2, and 5, 2. And now we can go ahead and look at the bottom one. We've already used a prime, so we're going to do it. We can do double prime. And so here we have our C, the right angle, so this would be C double prime. So I just put 2 little commas up there. A is going to flip all the way across to down here, so this is going to be A double prime. And then B is going to flip across right here, so it's going to be B double prime. And to figure out what our new coordinates are, just use our algebraic expression, x comma y, and it becomes x, which stays the same, and then the sign changes on the y. So here we'll look at C first. Our x stays the exact same because we're not moving left or right. So we'll have -2 still. And then we moved from up to down, so we're going to have our sign change, and that 2 is becoming a -2. So for C double prime, you'll have -2, -2. And then we're going to look at A double prime. We'll have -2 for our x, which stays the same. And then our y is 6. So that's going to change to -6. And then we look at B prime, B double prime. X is -5, it'll stay the same. And then our y is 2. We're going to just change the sign to -2. So B double prime, you'll have -5, -2. So when we're just creating and finding our new points, just use the algebraic expression. We know that the signs are just going to change. For your practice problem tonight, you'll take this shape right here with points A, B, C, and D. A is -4, 5. B is -3, 3. C is -4, 1, and D is -5, 3. And what I want y'all to do is, for the first part, apply the algebraic expression for a translation, where you'll have x, y, and then change to x plus 4, y minus 3. So you're going to draw your new picture and label the points as A prime, C prime, D prime, B prime. And then for the second part, I want you to reflect it over the x-axis. So you'll take this shape and reflect it across. So you'll draw your new shape and the new points and label as A double prime, B double prime, C double prime, and D double prime.